Okay, so in the last session, we completed the implementation of single linked list, and we completed almost all the functions or all the operations on single linked list. So today we'll be starting with the second type of linked list, and the second type of linked list is called circular linked list. So today we'll be talking about circular linked list, and this is the implementation file of our single linked list. So what I would be doing, I would be trying to convert the same functions into the functions applicable for circular linked list. Okay, so we'll try to see the differences at what all points we have the difference between singly and circular linked list, and then we can go on implementing the different functions of circular linked list. Let me make it as circular linked list. Circular linked list. So, what is circular linked list? Now, if you remember about single linked list, so your single linked list is a collection of nodes which are interconnected to one another with the help of a single link, and the last node's next pointer always points to null. I repeat, the last node next pointer always points to null. Okay, so that is the idea of a single linked list. So uh, if I try to show it here, so H is my pointer which points to a node 10, which then points to say another node 20, which then points to another node say 30, and then finally the next pointer of this 30 points to null. Okay, so this is our single linked list. But when we talk about circular linked list, so what happens in circular linked list that the last node, instead of pointing to null, it makes a circular structure. So how it would be making a circular structure? Simply by pointing to the first node. So the last node next pointer always points to the first node. I repeat, the last node next pointer always points to the first node in case of circular linked list. Now this is the scenario. This is the scenario of a single linked list. And if I want to say what would be my circular linked list, so in my circular linked list, this last node would be pointing back to my first node, and this I can show with the help of writing here H. Okay, so the moment my last node next pointer points to H, and H is pointing to the first node, so I can say that my last node is also pointing to the first node. So here basically when I am writing H, I simply mean to say that the last node is pointing back to the first node. Okay, and this way it forms up a circular structure, and that's why it is called as a circular linked list. I repeat, that's why it is called as a circular linked list. Okay. Uh, Now, uh, this is the only difference between a single linked list and a circular linked list. And because of this difference, what happens that imagine that you are in a single linked list, and in a single linked list, uh, you are at the second last node, and suppose for some reason you want to go to the or you are at the middle of the linked list, and you want to uh, go to a previous node, so you need to start the traversing again. You need to start the traversing again. Okay, or from the second last node or last node you want to come back to the first node. In that case also you cannot do in case of a single linked list. But in case of circular linked list, with the help of this circular structure, you can at any point of time from the last node you can come back to the first node, and you can move circularly. Okay, so the only difference between single linked list and circular linked list is this only, that the last node in single linked list points to null, and in circular linked list the last node always points to the first node, back to the first node. So that's the difference between a singly and circular. And because of this difference, we have or we get few differences in the implementation part. Now, as far as your structure is concerned, there is no change. There is no difference in the implementation part. Just a minute, please. Okay, so the structure part for both the list remains same. So there isn't any difference. You have the data part where you will be storing the data, and then you have one pointer. So in singly also we have one pointer, in circular also in every node we have a one pointer. Now just for our convenience, we can change this SLL to CLL. Okay, so wherever you have the word SLL, that can be changed to CLL just to make it circular English. That's all. And from implementation point of view, it doesn't make any difference or any sense. This is only from a logical point of view that we want to call our structure as CLL. Okay, and you can keep it a general name also. For example, node. Earlier we used to call it node, so the same we can keep. Okay, so I will be changing that all SLL to all CLL that we can do. So I need all SSL to be replaced with CLL. I want to make these changes. Replace all. Okay, done. So now we have made that change, and the first function that we'll be starting with is obviously insert at end. Okay. Now please hear carefully what we are going to do. We are not going to change the conceptual part. What I mean to say that whatever we used to send to this function in case of SLL, the same thing we'll be sending in case of CLL, and the same thing the function would be returning. Okay, so we are passing a head pointer of the circular linked list, and then we are passing the data to be inserted, and then the function is returning a head pointer. So inside this, the same story, we'll be allocating a space. If the space is not allocated, then not enough memory, then make up the data part of the allocated memory. P of data equals to D. Make up the next pointer part. P of next equals to null. And then if H is null, it means that my circular linked list is empty. Now in this case also, your when the list is empty, the head pointer points to null. Okay. So if H is null, we simply say H equals to P. Else, we need to traverse and we need to go to the last node. So temp equals to H, and then while temp of next not equals to null. Now this is the condition for a singly linked list. Now can you tell me what should be the condition for a singly linked for a circular linked list? Yes, please. Can you tell me the condition for a circular linked list? You can post your answer into the chat box. Or you can unmute your mic and say. Am I audible? Instead of null, we'll have the first element. Next of last node points to the first node. Yes. So next of last node points to the first node, and yes, temp of next not equals to h. So while temp of next not equals to h, temp equals to temp of next. And then finally we'll be writing temp of next equals to p. Okay. So this is perfectly right. Only one thing we need to change here, apart from this condition, that this p of next equals to null. Here we have written p of next equals to null. And p is going to be my last node after insertion. So p of next should be h. Okay. So we should write here p of next equals to h. So what I do here, uh, changed for, I just make a comment, changed for the CLL. Okay. So this way we come to know at what all points we have made the change. Here also I say changed for CLL. Okay. So now you can see that in the entire function for insert at end, what we have done, it is completely the function of SLL. Only all SLL have been changed to CLL. And then finally, these two statements are changed. This P of next equals to null, it was into SLL. And into CLL, we are writing P of next equals to H. And then this condition, which was while temp of next not equals to null in case of SLL, this has been changed to temp of next not equals to h. Okay. So with this change, let us see that are we in a position to create the circular linked list. And to check whether the circular linked list has been created or not, we need to check it with the help of a display function. So next, let's move to a display function and let's try to change the display function for CLL. So if h is null, so linked list is empty. Yes, the condition is same for SLL and CLL. Else struct CLL star TMP, and this is to count the number of nodes. Then temp equals to h, and then here I can say circular linked list content. And while temp not equals to null, print temp of data, temp equals to temp of next. Then here we are counting the number of nodes, and accordingly we are printing the size of a linked list. Let me comment out these two things, which is generally not required. So yes, can you tell me where all at where all points I need to make a change? Time equals to h, it will be there. We will be starting from the first node. Now here it is while temp not equals to null. So do I need to change this condition for CLL? This is the condition for SLL. What condition should come here? Yes, come on. Yes, please. Can you tell me? Yes, I got disconnected. Now I am connected back. Now, can you tell me? We were discussing about this point while temp not equals to null. So, in case of CLL, in case of CLL, what should happen? What should be the condition? Temp not equals to H. Any other student? What should be the condition here in case of CLL? Same as SLL, I think. No, it cannot be same because in case of SLL, it is null. In case of CLL, there is no null. In case of CLL, no node points to null. All nodes points to each other. Okay, the last node would be pointing to the first node. So there is no point of null in case of CLL. And if I make the condition as temp not equals to null, so what will be happening? That my condition fails at the very first check because we are initializing temp to null. Sorry, we are initializing temp to H, and if we are writing here temp not equals to H, so our condition fails in the very first check because here only we have initialized temp to H, and then here we are making a check while temp not equals to H, but temp equals to H because it is pointing to the first node. Temp is pointing to the first node, so we'll come out of a while loop. Okay, so what do we need to do then? Temp of next not equals to null. Okay, sorry, temp of next not equals to H. Temp of next not equals to H. So if you write temp of next not equals to H, so what would happen that you will miss the printing of the last node. So after the while loop, you need to write this printf once again. Okay, because you will be missing the printing of last node. Last node would not get printed. So after the while loop, you need to print the last node content after the while loop. So what can be done? Safe way to do that is, you can make use of another loop. Can you tell me which loop we can make use of over here? I remove this. Yes, obviously we can make use of a do while loop. Very good. So Control V, and then I write here do. So temp equals to H, it is pointing to the first node. We come inside the do while loop. The good point or the beauty of a do while loop is that it executes at least once. I repeat, do while loop executes at least once. Okay, and that's what we want to do here. So we'll be displaying the content of the first node, then immediately we are shifting to the next node. Okay, our temp pointer would be pointing to the next node. Okay, so in that case it won't be equals to H, and if it equals to H, then we can say that it was the only node which we need to printed, and that got printed. Okay, so do while loop is the best suited loop for this condition or for this scenario. So we'll be making it of a do while loop. Okay, so this is the change we have done. Can say change for CLN. So in fact, we have changed the loop, not only the condition, but we have changed the loop. And then we are displaying the size of a list. That's fine. That's perfectly fine. Yes. I save it. Then we go to our main function. Let's see everything is fine there or not. We have a header pointer. We are initializing head to null, and then for the insert, we are calling insert at end for CLL, and for the display, would be calling the display. Okay, so we can check this code. I save it, I compile my code, and before showing you the output, I need to present my entire screen. So let me do that. Okay, so now I am presenting my entire screen, and now I can compile this code. Okay, so code got compiled. The file is session22.c. I go to my directory, and here, yes, I have the application session 22. Let me check with you people. You can see the screen, right? Please reply. Okay, fine. So this is the execution of our CLL program. I go for a few insertions. So I insert 10, and then I insert one more node, say 20, and it got stuck and it got terminated. The program got terminated when we tried to insert for the next time. So it means that when we are inserting the second node, there it is creating a problem. So let me check insert at end. Insert at end, p equals to null if h equals to x equals to p, else temp equals to h, while temp of next not equals to h, temp equals to temp of next, and then temp of next equals to p. Yes, so that's fine, absolutely fine. What's the problem into that? Which function we are calling there? Okay. Insert at end. P of data equals to d, and p of next equals to h. Yes. I should not write this statement over here. Can you tell me why? Can anyone tell me why I should not write this statement over here? This statement is perfect, no doubt about it, but I should not write it here. You know why? Let me tell you. When the first node is getting inserted, when the list is empty, so your h is null. So when h is null, so this p of next equals null. And when p of h equals null, the node gets inserted. H starts pointing to that node. But that node's next pointer is not pointing back to h. It is pointing to null. So this way, our list is not getting created properly. So see here carefully what I am doing. Only one change. What a change! I am removing this statement from this point, and I am putting it at the end before returning. Okay, so it is common for both if else, and I am putting it over here. That's all. I save my code, and to recompile my code. Code is running, so I need to restart. Okay, let me compile my code. Okay, code got compiled. Let's execute it. Session 22. Insert. I want to insert 10. 10 got inserted. One more time. Insert. I want to insert 20. Now 20 got inserted. One more time. Sorry. Insert. I need to insert, say, 30. Got inserted. Now let's display. Okay. So circular linked list contain 10, 20, 30. Size of list 48 elements. Okay. 48 bytes. One more insertion. So I insert 40. I display 6. So 10, 20, 30, 40. So now it's going on perfectly. Okay. So this is how your circular linked list insert at end function and the display function would be implemented. And I have shown you where all points we have made the changes. And now what we can do that now we can think of changing other functions. So which function you want to get changed right now? It is only with the condition you need to play off. You need to play with the condition, that's all. And when you play with the conditions properly, your work is done. So basically, there are no major changes as far as implementation of SLL and CLL are concerned. The implementation are almost same, and we are intentionally keeping them same, so that we can study the differences. We would come to know the differences, and from implementation point of view, it becomes quite easy for us. You implement one program, you remember the differences, and you are ready with the another program. That's all. It is as simple as that. Okay, and that's the reason we are keeping the code base as same as possible. So, for example, this is insert at beginning. Okay, so for insert at beginning, I am changing the same function of SLL to CLL. So this remains same, and yeah, this statement which we have changed for insert at end, we would be changing this also. And what I need to do that let me comment it out. Of course, safe coding I can keep it, but better to comment it out. Then if this is my first, then I would be saying h equals to p. Else this is insert at beginning. So my first node is going to get changed. Okay, so that's why we are writing p of next equals to h, and here we are writing h equals to p. That's all. And in fact, what we need to do here, we need to simply write p of next equals to h. You can tell me the changes in the chat box if you are also suggesting the changes. So p of next equals to h, and if h equals null, then h equals p, then the next pointer is pointing to h, so our list is done. If that is not the case, if my list is not empty, if there are some nodes, so in that case also I would be making the first node as the second node and this new node as the first node by writing p of next equals to h, and then finally writing h equals to p. Okay, now there are some redundancies in this code, and if you can see the redundancies, so the redundancies are like in the if part you have h equals to p, and then in the else part also you have h equals to p. Okay, so after that, if you see, so you have p of next equals to h over here, and in the else part also you have p of next equals to p. Okay, so it means that whether you are in the if or you are in the else, this p of next equals to h is going to get executed. Okay, because it is before if. And whether you get into the if or you get into the else, in either of the case, h equals to p is also going to get happen. Okay, so there is a redundancy in this code, and this redundancy can be removed, or the code can be made more simplified by simply writing like this: p of next equals to h, which is already there, and after this I need to simply say h equals to p. I repeat, p of next equals to h, and then h equals to p. And whether we'll be able to solve the issue with this? Yes. What I mean to say, that I'm going to remove this entire part, and then I'm simply writing this. But I mean to say this. So with this, are we able to uh, get what we are expecting? I mean to say the data part is set, then p of next equals to h. So the p node becomes the first node when we write p of next equals to h, and then the moment we write h equals to p, so the header starts pointing to this node, and then your list is intact. But suppose your list is empty, there is nothing. So in that case, this p of next equals to h. So this would again become p of next equals to null, and then h equals to p. So it becomes a first node, but the next pointer of this first node points to null, and this should not happen. It should point back to the first node. So what should I write? Yes, come on. Or we need to write like this. I remove this part. Let me comment it out both. And then if my list is empty, so I would be just a minute. If the list is empty, so in that case, first I need to initialize the pointer p. First I need to initialize h, and else p of next equals to h. Yes. Am I correct now? If h equals null, if it is empty, then h equals to p. So h starts pointing to p, and then p of next equals to h. So it becomes a circular list. And if it is not null, if there's something into it, and this is insert at the beginning, so uh, this part. What's happening? Why it is getting confusion here? Can anyone tell what's happening here? Why it is not getting done? This is insert at beginning for circular linked list, and if there is no node, if my h is null, so h would be the first one. Ah, this is unnecessary things. Let me make use of one temporary pointer, and I say temp equals to h, and then I simply say h equals to p, so h starts pointing to the first node, and then I say h p of next equals to p of next equals to 10. So what would be happening if it is if yeah if h equals null, if h is null, then p of next equals to p, else p of next equals to h, and then h equals to p. Am I correct now? Please see this. If my list is empty, if h equals null, so in that case, this node is going to be my first node, and the next point of this node should point to itself. So p of next equals to p. Else, if the list is not empty, if there are some nodes, so this node is going to be the first node. So the next point of this node is going to be point to the first node and earlier first node. So we'll be writing p of next equals to h. And once this is done, then we can safely say h equals to p. So h starts pointing to this node and this node becomes the first node. And then the remaining list remains intact. So let's check this code. Because of this only it got little tricky, and we spent so much time onto it. This is insert at beginning, and let's compile it. and to restart. Okay, let's execute. And there's nothing in my list. Let me display. It's empty. Now let's try to insert at beginning, the second option. And I want to insert 10. And let's display. Okay. Now there was nothing in the list, and then we inserted at beginning when the list was empty. So our node got inserted, and now there is already a node into the list. So 10 is there. Now let us insert at end, the first option, 20, and let's display. So yes, we got two nodes, 10 and 20. Now we'll go for the second option, insert at beginning, the second option. And this time I want to insert, say, 30, and 30 should become the first node because this is insert at beginning. Let us display. Oh, so again, we are not handling the pointer properly, and when we try to insert at the beginning, when there is already when there are already some nodes in the list, so it is not getting done properly. Okay, and for that, let's stop this. For that, we need to come back to this code, and let's see, insert at the beginning. Insert at beginning. Insert at beginning. P of data equals to B. This is fine. We come to the else part. P of next equals to H. This is perfect. Then H equals to P. If H equals null, then P of next equals to P. So it will be pointing to itself, and this is the first node. And then finally H equals to P. Yes, fine, perfectly fine. What's the problem? Then we call insert at end after inserting the first node. Let me execute it again, and this time we'll not call insert at end. Let's simply call insert beginning only. So I insert 10 and get displayed properly. Then again insert beginning, and I insert 20. No issue right till now. Let's display. Okay. So basically what's happening at your when the node exists, insert at beginning. When the node exists, so we come to the else part. And in the else part, we say P of next equals to H. And then H equals to P. P of next equals to H. The else part, if my H is not H equals to P. I don't know. H of next equals to P. Why H of next equals to P? H is pointing to the first node, na? If you say H of next, so basically we're talking about second node. Here we say P of next equals to H. So the next pointer of this new node points to the first node. And then we make the first new node as a first node by writing H equals to P. It should be correct. Problem, I think, is still here. H equals null. Then P of next equals to P. Oh yes. So we made a conceptual mistake over here. What we did that if the list is empty, so P of next equals to P, else P of next equals to H. That is perfectly fine. But what's happening that in a circular linked list, please see carefully. In a circular linked list, the last node always points back to the first node. Okay, and for every insertion and beginning, the first node is getting changed, but we are not changing the last node pointer. I repeat, we are not changing the last node pointer. So basically, the last node pointer should get changed after insertion of a node in the beginning, because the last node next pointer should be pointing to the first node, and we are changing the first node. So we need to handle this case, which we are not handling here. So the moment in the else part, when we come here and we simply write P of next equals to H. Okay, so new nodes next pointer is pointing to H, and then we are simply changing H equals to P. That's fine. But here, when we come into the else part, we know that your list already exists. So when the list is already existing, we need to go to the last node and we need to make the next point of the last node to point to this new node. Else our list is not properly forming. Okay. So in the else part, when you do this, so you need to have this, and before this or after this, wherever we want, we need to go to the last node. N equals to H, and then while temp of next not equals to H. 10th equals to 10 for next. Okay. The moment you reach the last node, then you need to make the next point of the last node to point to this new node. Oh, silly mistake. And finally, this would come, and this should work. Let's check. What is all the data? Let's execute. And I want to check insert beginning, second option. I go for the data 10. I display it. Okay, it got inserted properly. I go for again insert beginning. Next data 20. It should be inserted before 10. Let's display and see. Now it's happening. So 20 is my first node and 10 is my second node. Then I go for again same option. I go for 30. Let's see whether it got inserted or not. 6 of them. Okay, it's got inserted 30, 20, 10. I go for insert at end, the first option. I insert 40. Now 40 should become my last node. I go for the sixth option. And yes, it is getting inserted properly. Okay. So we missed one part for insert at beginning, which we did not do into the SLL because it was not required, but in CLL it was required. The moment you change your first node, so your last node pointer should also be changed because your first node has been changed. And in CLL, the concept is what? That your last node always points to the first node. Okay. So your new node is getting inserted at the beginning. So your last node next pointer should point to this new node. And that we missed when we tried to change the function of SLL, insert at beginning function of SLL into CLL function. So this is the additional part which we need to require to do. And after doing this, now we can see a proper implementation of CLL. So there are a few additions into the insert at beginning function of SLL to make it working for CLL. So please make a note of this. It took a lot of time. Okay, so that was insert at beginning. Then insert after. P of data equals to D, P of next equals to null, let it be for safe coding. Then temp equals to H, while temp not equals to null. And at the same time, temp of data not equals to K. Temp equals to temp of next. This is about searching for the given node. This is when you reach the last node. But in case of CLL, the condition should not be time equals to null. It should be something else. And if you write your time equals to H, here you already have time equals to H. So your condition fails in the very first check. So you need to come out with some other condition. Then if temp not equals to null, so it means that you have got your node. So I should write temp not equals to H. That is the thing that the entire list has not been the entire list has not been searched, and we have got the given node. So p of next equals to temp of next. This is after. Okay, so it is fine, and then temp of next equals to p. Else the display message given key does not exist. So what should be the condition here? Yes, please let me know what should be the condition here. While 10 not equals to h, if you put up that condition, then the loop would fail there itself. If I write this, then the condition fails here itself. And if I write temp of next not equals to h, and in that case it won't check the last node. Okay, and you need to explicitly check for the last node. So here I need to put up one more condition. If say temp of data not equals to k, then temp equals to temp of next. So this way we can handle the situation, or you can make use of the while. And let us see whether we are able to implement this insert after properly or not. So let's check it. Stop this. I need to stop this also. Just let me save. Stop this. See, this chapter English is full of pointers, is a little complicated. You need to give your 100%. You need to be very, you need to put all your concentration. And this way only we can understand, this way only we can sort out the issues. Keep on doing it. See, I have the complete ready code with me. My complete CLL program is ready with me. I can simply open up that code. I can show you the code, and I can simply explain it, and I can get it done. But I'm implementing along with you. I'm trying to convert the SLL program into CLL program so that you can understand it properly. And we are putting a lot of time into it. You should understand. So basically, we are running short of time, but still I am trying to ensure that you understand the implementation part carefully, and that's why I am doing it along with you. Otherwise, I repeat, the CLL program is separately ready with me. I can simply open that program, I can show you the code, explain you the code, get it run, and all the conditions properly done. So you can do that also, but and that will take very less time. But I want you people to properly understand it, and to properly understand it, you need to concentrate a lot. You need to be there with me all the time, and you need to see what all changes we are doing, where we are stucking, where we are facing the problem, then how we are resolving the problem. So if you understand this, then only you understand it properly. Otherwise, it's simply a formality kind of thing. So insert after we have done. So let's first insert few nodes. I insert 10, then I insert 20, then I insert one more node, say 30, display 10, 20, 30. Now let's go for insert after, and let's say that we want to insert after 20. Okay, so I will be going for the third option, insert after. My data is suppose 35, and I want to insert it after 20. The key element is 20. Okay, so it did not show any error message over here. So let's display it. Let's see whether it is getting done or not. So yes, our 35 got inserted after the 20. This is done. This is circular linked list, and we need to check for a few other conditions. What I mean to say that let us now try to insert after the last node. So now we know that in a circular linked list, the last node points back to the first node, and then only it becomes a circular linked list. And now let's try to insert after the third option. And my data is suppose 40, and I need to insert this after the last node, which is 30. Let's see. So here it does not show any problem. Let us try to display whether the list is intact or not. So yes, the list is still intact. After 30, a node 40 got inserted, and 40 is pointing back to 10. 40 is pointing back to 10. And this way our list is intact, and it is still a circular linked list. And let us check for one more condition. I want to insert after the first node, and that should also work. So my third option, insert after, and I want to insert say 15, and I want to insert it after my first node, which is 10. It says given key data does not exist. Okay, so it should not have been inserted. Yes, it is not being inserted. And what's happening here? It is missing out the first node. It is not checking the first node. Now see here carefully what's happening. I go for the third option again. See here, our first node is 10. Okay. And I'm going for the third option, insert after. Insert after. My data I want to insert is 15. And my key element is 10. But now it is saying that the given key data does not exist, though it does exist. Okay, so let us see into the implementation part. Where is the problem? See, this is how we need to understand, and this is how we need to implement. Otherwise it's not proper study. So insert after, and it is not making a check for the first node. Temp equals to h, temp is pointing to the first node, while temp of next node equals to h, and at the same time temp of data node equals to k. So temp of data is k, so this won't be done, and temp equals to temp of next, this will not be happening. Will be coming to this part. If temp of data node equals to k, this condition is also false. This won't be done. And now when you come to this part, if temp not equals to null, sorry, not equals to h, so temp is h because it is pointing to the first node, and the first node is the given node. So if temp not equals to h, then only we are coming into this part. Else we are saying given key data does not exist, which is false. So how to resolve this? How to resolve this? Any idea? Are they understanding where the problem is? This condition is a condition to say that we have checked the entire list and we have not found. If temp equals to H, we mean to say that we have checked the entire list and we have not found it. So basically here I need to put one more condition, and at the same time temp of data is not, oh sorry, no, not here. Uh, the else part I would be doing this. No. So here I need to change this. What I need to say? I need to reverse the conditions. Please see what I'm doing. Instead of not, I would be saying equals H. Uh, so if this equals H, it means that my entire checking has been done. So this should come over here. And this should come in the else part. Please try to see what I'm trying to do. So what we are saying that if this m equals H, it means that the entire list has been checked and we have not found the key. So, and at the same time, m equals to H, so key does not exist, else do this part. So not only time equals to H, but at the same time, the data is not key. Temp of data is not key, that is k. So if temp equals to H, and at the same time temp of data is not k, so the key does not exist, else we do this. Okay, now let us test it, and again we need to test it for all the conditions. So I need to stop it and reopen it. Compile the code, execute the program, and first I would be doing some insertion. So 10 and 20, and one more insertion, say 30. And this is our list, 10, 20, 30. Then insert after, third option. And let's insert 25 after 20. Let's see whether this is getting done or not. Go for the sixth option. Okay, 25 is inserted after, sorry, 25 is inserted after 20. Yes. and then again insert after, and I want to insert 35 after the 30, after the last node 30. Let's check. Yes, getting inserted properly. Now let's go for the last condition. I want to insert after, and I want to insert 15 after 10, after the first node, which was not getting done earlier. Okay, so no message that the given key does not exist. Let's see whether it's got inserted or not. And yes, it got inserted. Now check for the condition where the given node really does not exist. So I go for the third option, insert after, and I want to insert say 50, and I want to insert it after 50, which does not exist. And yes, now we are getting a message that the given key data does not exist. Okay, so now this is insert after, which is working for all the condition. Insert after any intermediate node, insert after a last node, and insert after a first node, and then trying to insert after a node which does not exist. So now our implementation is coping up with all the conditions for the insert after, and this is how we need to change, and this is how we need to implement the things. Okay, so a few more changes. Apart from basic changes, we have changed the condition, then we have changed the if else part, and this is how we implemented the insert after for the circular linked list. Okay, so which all function we have modified? We have modified insert at end, insert at the beginning, then insert after, and then display function. So all insert functions of the SLL have been converted into the insert function for CLL. Remove functions are remaining. The display function is also changed. Let's change this remove last. Only one function. Remove last. So this is if h equals null, so list is empty. Then else temp equals to h, and I need to go to the second last node. So cleave equals to temp, while temp of next not equals to h instead of null. So while temp of next not equals to h, cleave equals to temp equals to temp of next. Yes, then if h of next equals null, so this is the last node, so h equals null. Oh, sorry, h of next equals to h, circular linked list. So if this is the case, h of next equals h, so this is the only node which has to be removed. So in that case, we say h equals to null. Else, prev is pointing to the second last node, so prev of next equals to h instead of null. Prev of next equals to h, and then free temp, fine, and last node removed, done. Anything else we need to do into this? I don't think so. So your remove last is also ready, and let's check it. I need to again stop it. No problem. Compile the code, then I'm running the code. Let's have some insertion. 10, 20. So two nodes are there. 10, 20. Let's remove it. The fourth option, remove last. last node removed. Let's display 20 should be removed. And yes, 20 is removed. So you have only one node, that is 10, which is the only node. Let's remove that node also. So the same option, fourth one, it says last node removed. Let's try to display the list. And yes, the linked list is empty. We are getting the message linked list is empty. Then let us try to remove again. List is empty. Fine. Let us try to insert few nodes. So I insert 5. Then I insert one more node, say 6. Let us display. 5 and 6 got displayed. Okay. So 2 nodes are there. Let's remove it. Last node removed. So only 5 should be there. Only 5 is there. Okay. So remove last is also now changed. And with minor changes, we are able to convert it into a function for CLL. Remove last. We have changed only this condition and this condition and this. So with these 3 changes, we are able to make it ready for CLL. Changed. And this also changed. Okay, so now we are ready with the remove last for CLL. You can check for the remove given and remove before. Once you change these 2 functions, then your program for circular linked list is completely ready with you. Any questions into this? Any query, any question from your side? Okay, so today's session was a little exhaustive. We could not discuss anything else. We were solving the issues we faced while converting the function of SLL into CLL. Please go through the code. I will be sharing this program or today's session notes and explanation into the Google Classroom. Please go through it 2 or 3 times, then you will be understanding it properly. And let me tell you once again, we have changed all the insert functions, and we have changed the display function, and then we have changed the remove last function. So all those are working properly for CLL. You can check for all the conditions. Let me stop the recording part.